morning, everyone. Hi, and thanks for joining our today OpenShift Coffee Break. And good morning, Natale. I think you have some issue with your
Yeah.
microphone. That's fine. And good morning
Oh,
to our. Good
No.
morning. Welcome, Natale, again. And good morning
yeah.
to our guest. Good morning, Alex.
Good morning.
Do you like to introduce yourself? And before your introduction, please have your coffee today, as always.
Good morning, everyone. And today, you know what? I have this, but also I'm there. I have the refill, so I
So,
can just refill right now and have my coffee shot live demo.
you're full of surprise, my friend. Natale.
Today we can do like 2 hours OpenShift TV session, coffee break, and Natalie will not get out of coffee for sure.
Say we could end up to have Natalie too excited with the full So please,
Cloud
Alex,
native.
do you want to introduce yourself briefly, and then we can start?
Yeah, well, my name is Alex Soto. I work in here in Red Hat. In fact, I work in the same team as Natalie, and yeah, I'm really like to just all the Java world, the Kubernetes world, the Kubernetes ecosystem, like Istio, Knative, Tecton, Argo CD, and so on. It's something that these days I'm working pretty much, and yeah, of course, also Java, and these days especially Quarkus.
Okay, cool. I know that you are going to talk about distributed deployment of microservices and dealing also with transaction in the microservices world. So if you would like to give us some insight, what does it mean really dealing with transaction in a microservices world and microservice architecture?
Yeah, well, yeah, I've got some slides. So if you want, I can share my screen. You can see all the things in the slides, and you can understand exactly the current spacing in the transactions and microservices. And also, yeah, I prepared some examples, and yeah, we can talk. And yeah,
Sure, please.
so let me share my screen. I think that now, unable to share the screen.
Something we have to do in our backstage, but we didn't because we were talking about distributed transaction. So we were anticipating our coffee break.
Yeah, please.
So wait, let me. It says update system permissions to allow screen recording for the browser.
If it is slides, I can share the slide for you if it's on Red Dot side. I don't know.
Yeah, but then how the demo?
No, we definitely need you. So what about? I think it's a permission on kind of a browser Mac stuff.
Yeah, probably yes.
You have to go into permission and say something about it.
But it's weird because I use Airstreams maybe last week or something. Yeah, and it worked.
In the while that Alex tried to figure it out.
I think we can remind to our guests, please use our developer sandbox. Let's give in the chat the link to try, play, and enjoy our developer sandbox. Let's remind our what is Natale, the developer sandbox, Red Hat developer sandbox, and why our developer guests should subscribe to developer sandbox.
Right, Fabio. So in fact, Alex is going to do a demo on developer sandbox, which is an environment free to use, a kind of a cloud Kubernetes environment where you have a multi-tenant access to an OpenShift cluster. And there you can start deploying your application. You can start trying out even databases. We have a new offering called Roda that lets you link databases as a service. There's a component called the service binding that I think Alex is going to use also. That can be used to link databases or queue system or even Kafka Kafka data streams. About Kafka, Fabio, there's also managed Kafka in offering in SaaS. Basically, you can try to use Kafka in your applications, and you can attach your Kafka workloads into that from the topology view. So I put the link in the chat to the sandbox. It's free to use. If you want to register, it's free to use. You have this free account on OpenShift. Yeah, I think we have also suggestion from the chat. Thanks, Abby, for technical suggestions.
Well, how is going, Alex? Welcome back.
Not so good. Not so good.
Did you
because I don't know why
your...
I cannot select Chrome. Okay, wait. Let me.
Oh, really?
I think so. Okay, let me try. Yeah, like now maybe it's going to work. Wait. Yeah.
Okay, no problem. I'm confident, Fabio, that this time we will make it.
Yeah, Sebastian provided some the right suggestion, but so it should work. I always do my mistake when I call Sebastian. That's
Sebi, sorry about second time.
Shame on
public audience. I mean,
yeah, shame on me. Shame on me. Next time we will meet face to face. Yeah, you will. I will offer you some beers.
Fabio, let's take this opportunity to also talk about our rich schedule we have in April, upcoming schedule on OpenShift Coffee Break.
In the meantime,
because we have something very cool coming up. I think there's also Andrea that invited one of our colleagues to talk about more, keep talking about Camel K. And we have also other colleagues joining again, talking about
how OpenShift can enhance and leverage GPU for AI/ML workloads. Is part of is a third-party companies that certify the solution on OpenShift. Should be really Alex.
Yeah, now let's see if now it's working. Yes,
there we go.
Yeah, great.
Okay, I think that you can see my slides right now.
Yes. If you go to
presentación, full screen
de dispositivos.
Yeah. Then today we're going to talk about transactions in the microservices world. And yeah, the slides are open, so you can check the links. They will share with you, and you can access them. You can reuse it. They are public. So yeah, my name is Alex Soto, and my tutor is Alex Soto B. I'm director of developer experience at Red Hat, and well, basically I'm the author of Testing Java Microservices, Quarkus Cookbook, Securing Kubernetes Secrets, and these days I'm writing GitHub's cookbook with someone that is also in the call today. Which is Natalie. So we are co-writing this book together.
Here we go.
And my tutor is, as I said, is Alex Soto B. If you want to be updated with Java news, Kubernetes news, or if you have any question and you want to ask me on Twitter, then you can follow me. And we need to think that maybe 6, 7, 8 years ago, our applications were like something like this in the lab, the old school architecture where we've got our monolith application with all the code inside, and then we've got the database there, and all the operations were done against this specific database, and everything was in the same context. But let's say that this, 6 years ago, we decided it could be a good idea to breaking down this monolith into a services architecture, or that some people say microservices architecture. And well, in this case, we've got several services, all of them interconnected. And one of the key points is that each of these microservices has its own database. Then, how we can deal in this model when we are with transactions? In the past, it was really easy. We've got our monolith application. We just could start a transaction at the beginning of the request and just end the transaction after the request. And in this way, we get it atomicity consistency, isolation, and durability across all the requests. And that was possible because, as I said, we've got a monolith architecture. But what happened when we've got a microservices architecture, when we've got several services, all of them interconnected, right? And each one having its own database. Okay, there is one approach that is named two-phase commits, or 2PC, that, as the name suggests, there are two phases when we are starting a transaction. One is the prepare phase, another one is the commit phase. And it works like this. We've got, first of all, several services. In this case, I just put it two to simplify the use case. Then, when this service gets a request and it needs to insert something into the database, it says, okay, I'm going to insert this into the database and I'm going to send a message to a coordinator. So there is another piece of software out there that's named coordinator that receives something from the service A saying, hey, I've inserted something into my database, but I cannot commit the transaction yet because I know that there is other operations there. And of course, then there is the service B that says, okay, now I've received a request, which it's coming maybe from this service, maybe not. I'm doing the insert, and it says to the coordinator, hey, coordinator, I'm done. So I'm done, it means that I'm ready to be to commit the transaction. Then all these results are received to the coordinator, and when the coordinator has the results of all the services involved in this, let's call it macro transaction, it just communicates to each of the services saying, okay, everything worked as expected, all your services work correctly, so just commit your results. Or if we've got, for example, this service work correctly and this throws an error, maybe a foreign key violation, then the coordinator will say, okay, in this macro transaction, there was one service that failed. It means that all of you need to do a rollback. This is a two-phase strategy. And it works, but notice that you are sending 4 messages for each microservice. Right? You see here, I'm sending this message, then the coordinator send me another one. And here, coordinator is sending me a message, and I'm getting, okay, it's work or not. So I'm sending 4 messages for each microservice. So if you've got like 100 microservices, okay, there's a lot of messages. This also makes things work really slow. Keep in mind that you cannot commit or you cannot rollback anything until all the microservices involved in that transaction finishes. So maybe it's 10, maybe it's 20, maybe it's 2 services. So you see that at the end, you need to wait as much time as the slowest microservice. Then also, I see that most of the things needs to be done in a synchronous way, not in a synchronous way, because you need to wait until all of them finish. And finally, let's say that this solution is not for high throughput applications. So let's introduce an example and see another way of doing this. And in this case, I just prepared a simple example, but it will help us to visualize everything. And it's a cinema booking seat system where you have the cinema, and then you can choose a seat, and you make the reservation of the seat. Then you just do a checkout, so you pay the seat. Then there's a payment gateway service, just connects to the bank. It makes all the transaction. It says that the payment goes okay, and your seat is booked. Okay, this is more or less how it works. And of course, we've got a database where we are storing the seats that has been reserved. Okay, it's a really simple service architecture with 2 services, one of the cinema booking seat, another one with a payment gateway. This is from the point of view, if you want, like the front end plus what's happening in the back end. You see that here I got the cinema. The front end is coming from an example from LRA. You will see it in a few moments. And you've got the cinema, and you select the seat. Maybe in this case, I selected the seat number 34. And then I want to reserve this seat. Then when I push this button, what's happening is that I'm just sending an HTTP post request to /booking/create. So I'm just creating a booking. And apart from a lot of things, I'm just reserving this seat inside the database. So I'm just saying the seat number 34 for this room has been reserved. Then after I finish this, I'm presented with this screen saying, okay, now it's time to pay. And to pay, you just here put in the amount and so on. You put pay, and when I push pay, I'm going to the cinema booking seat service. I do a request to /payment/pay that at the same time will do a checkout to the payment gateway. So in /pay, and then finally we'll send the payment to the bank. So you can see that here there are things that might go wrong, that might fail. For example, it might fail when I'm inserting my reservation in the seat reservation database. That's one thing. But suppose that this thing works, but it fails while I'm doing the send payment to my bank. Maybe my bank is down, so now I got it a failure. So this use case is something that with a distributed transactions with the two-phase commit approach might not work, because in this case, there is no database involved. So I roll back to what? Because there is no database. And this is exactly what Saga's pattern is here. It's just to fix these problems, so you do not need to rely on the 2PC transactions. That's the first thing. And the second thing also solves the problem of transactions where there is no database involved. So Saga pattern, it can be known as a long life transactions because it's just a sequence of interleaved transactions. You can think like it's like a macro transaction that inside it has some sub transactions. And one of the things of all these sub transactions is that all of them needs to finish, or we need to apply some compensations, right? So it's like, okay, the transaction has failed. What I need to do, and it's like what I need to do to get the system back to the previous state where we didn't start all these macro transactions. That's the compensations that we need to apply. We'll see now in an example, okay? So we can say that a transactions in a Saga pattern is composed by sub-transactions, T1, T2, Tn. Each of these sub-transactions needs to define a compensating transaction. So if I apply T1, then if it fails in any of these other sub-transactions, I will need to do the compensation C1. If I do T2, then I will, if it fails T2 or T3 or Tn, then I will need to apply C2 and so on. So just to keep you in mind, it's that C1 and those T1, C2 and those C2, and so on. I know that now maybe it's like, oh, it's super hard to understand, but I've got a slide that it summarizes everything. Keep in mind that all these compensations needs to be idempotent, because you could want to execute these compensations more than one, and you are just changing the atomicity part of a transaction for availability. That's an important point. Then we've got this. We've got our system, and I want to reserve or book a seat. The transaction one is that I want to reserve a seat. And then, let's say that as a developer, I also define the C1. In this case, canceling the reservation of the seat. Then I've got another transaction which is send payment. So when I want to pay something, there is another transaction, T2, that if it fails, it means that I will execute C2. So if it fails T2, I will execute the compensation C2 and also the compensation C1. This is a successful scenario. I said, okay, I'm starting a Saga, so I'm starting this big transaction, and then I start reservation seat T1, then I end the reservation seat T1, then I start the payment T2, I end the payment of T2, and finally ends the Saga. So if everything works, it's fine, nothing happens. You've got here your receipt for being paid for the seat, and you got your ticket. That's fine. But what's happening if it's not a successful scenario? So you start the transaction, then suppose that you start the reservation of the seat and it works, so you end the reservation, and then you start the payment. So remember that when I show you the UI, you see that it was like a wizard, right? That first you select the seat, you do that you want to reserve, you reserve it, then you get it the payment, you pay it. So it's like two different sub transactions into this macro transaction. And what's happening if the start payment of T2 fails? Then what we will need to do is start compensating the payment C2 and the compensate of payment C2 and execute all the previous compensation logic. In this case, compensate the seat C1, compensate seat C1. Okay, so you're just, if you will, rolling back your business logic to the state before we started the Saga. In this case, it means on reserving the seat, and if you have already paid if the user has already paid, then get back the money. And there is another piece out here in the Saga pattern, which is the Saga execution coordinator. Because as it happens with the two-phase commit approach, you need a coordinator. You need someone who can coordinate all this execution. And also, apart from coordinating, it just stores the logs of what's happening in terms of transactions. So if there is a failure in the Saga execution coordinator, you can always recover to a known state. And finally, the Saga execution coordinator is the one that will detect that a sub-transaction has failed, and it needs to come sending all the requests to all the services saying, hey, you need to compensate, or you need to execute the compensation logic. So again, here is the same example, but with the Saga execution coordinator. I'm the cinema booking seat. It starts a Saga number 1. Then it starts the transaction 1. Then I do the checkout. The checkout gets a payment gateway T2, so it's the transaction 2. Then it finishes, so it ends the Saga 1. And finally, the Saga execution coordinator sends a request to the both services saying that the Saga 1 has been completed. And you can see here that I'm saying that the whole transaction, the whole macro transaction, it's named Saga 1. What's happening if there is a failure? Well, if there is a failure, it happens exactly the same. So it starts the Saga 1, then it does the transaction 1, it does the transaction 2, ends the Saga, but notice that there is a failure during the transaction 2. So what it does, the Saga execution coordinator is sending to the services that they need to execute the compensation logic. This one, the C2, and this one, the C1. How to implement this in Java? Okay, there's different ways to do that, but I recommend you using the microprofile LRA specification. You see, this is the microprofile spec. This is the microprofile 3.0. And I think that now it's like 4. And here there are some, let's say, some specifications that are under the umbrella of microprofile, which is the reactive streams operators, GraphQL, concurrency tools, and LRA. And LRA is for long-running actions, and it implements the Saga pattern. So you can easily take a Java application to follow this, let's say, or implementing this pattern. And here is the example we're going to see today using microprofile LRA specification, and you only need to annotate the methods with LRA. So here, see that it says this method create a booking. It's a JAX-RS method or endpoint at /create, as I said before, and I annotated with LRA. I'm saying this needs a new macro transaction. It needs a really big transaction, and see that I'm saying that this big transaction, it's not finishing when this method has stopped running its business logic. So it's like, hey, although this method finishes, the macro transaction is still alive, because remember that we said that a macro transaction is composed by sub-transactions. So I'm saying that this is a sub-transaction and it's not the end of the saga. So it starts the saga, but doesn't end the saga. And then also I just created another endpoint with compensate annotation. And this compensate annotation is just to say, when there is an error on any of the following transactions or sub-transactions, then to recover, to compensate what I've done in the create booking method, you just need to call me this thing. And this endpoint, the /compensate, is going to be automatically called by the Saga executor coordinator. So it's not something that you need to call by your own. It's something that it's automatically called by the Saga executor coordinator. You see here that I say that the sec one is calling me with the compensation endpoint. So for this reason, you annotate it here in this way. And then here I've got the payment gateway. And when I've done the payment, it means that I finish the transaction. So I'm just saying that I want to be inside a macro transaction. For this reason, I put it here mandatory. So it means that I need to be inside a transaction, and I put it here and true. It means that this is when I finish executing this method, then this saga has finished. This macro transaction has been finished. And you can see that even I can just get the macro transaction ID because it's always set in the header param. So if you want to learn more about microprofile LRA, this is the link. Here you see all the specification, because yeah, it does a lot of more things. And of course, now we're going to see a demo. And this is the link of the demo that you can deploy it on your own without no problem, because, and that's the point, it's going to be deployed in the Red Hat Developer Sandbox. I don't know if there is any question.
Not yet. There was a comment. Sorry, there was a comment from Pradeep saying that in the school we in the new school we have many databases. Will it cost us? So the question is, what is the cost of having multiple databases instead of having one single database for one single application?
Yeah. I would say that first of all, of course, the cost of that you need to maintain them. That's one cost. So it means that you need to keep them running, updating, and so on. That's one cost. Another cost is that, of course, you are deploying a database probably in a pod, in a Kubernetes cluster that's running in a cloud. So it means that you've got more processes running. So it's also a cost. And there is the cost of maintaining, let's say, maintaining the consistency between databases. You know that with microservices, we end up with this thing that is named eventual consistency. So with one database, you can do join between tables. But with multiple databases, you cannot join the data inside these databases. So you need to do this kind of joins, doing calls between services. So it's also a cost. I don't know if this answered the question. And maybe you've got another other points.
But probably, yeah, that's part of, let's say, of the game, to have different database instances instead of just the big ones. At the same time, correct me if I'm wrong, when you have to change something in just a business domain, the application, the impact in terms of a data model will be only that domain. Instead of change, and also in terms of unit test and side effects, instead of, if you have a big database, the impact to change all the data model, it is a bigger one. So there is always a balance between, let's say, computational cost, and we should also calculate what does it mean to have a big database running the cloud, or running also just bare metal, instead of having just smaller database instance. So I think probably that there is no just one answer, but it's just case by case, and let's see.
Also there's another big advantage is that that you can, I mean, that your throughput, especially on writing records, are faster with multiple databases than with just one database. It's like Kafka and partitions, that since you've got multiple partitions, you can write pretty fast because each of these partitions can be deployed in different machines. Then more or less you can think sort of the same approach, that if you've got multiple microservices and each of these microservices its own database, it means that you can write, let's say, requests in parallel, because the microservice A is going to write to the database A, which is going to write to this, and microservice B is going to write to database B, which is going to write to another disk. So you are also increasing the throughput of your application, having your multiple databases, one for each microservice. Okay, then let's see the demo of that I've prepared. It's exactly this cinema approach. Okay, I've got here Red Hat sandbox. You can just open create your account and then clone the repo that it was shared, which is, I think, that's been shared here, which is this one. Well, it's this one. Here, let me see if I can copy. It's this one. Okay, here is the source code. You can see the source code of the payment and the seat booking, everything. It's implemented in Quarkus, but at the end, Quarkus is just using the microprofile LRA specification, so it should work in any other Java project. Now, first of all, let's deploy the coordinator. Remember that I said that we need a coordinator to coordinate all the sagas, and in this case, I am just deploying one of the coordinators that is Narayana. It's provided by the JBoss team, and it's implemented in Quarkus. Okay, so it's a LRI coordinator. There are others, but I would say that this is the most popular one. If I'm going here, you see that it's being started, and if we check the logs, okay, you see that it's just a Quarkus application. That's an important thing. It's just this. Now, the other thing that we need is a database. Remember that I said that our example had a database where we put there the reservations. And in this case, I just decided to use a MongoDB. I'm going to just add, that's a pretty cool thing of Sandbox. I'm going to add databases. Okay, here you can just use Crunchy or MariaDB, but in this case, I'm going to select MongoDB. I just instantiate the template. The MongoDB service name, I think it's MongoDB. Let me check it. It's just one moment to see. Wait, here. This is the application. Now we're going to get with the code as well. But first of all, let me go to resources. And you see here that is MongoDB, so it's okay. The username is super secret, Alex, and the password is also secret. The database, its name, Cinema. Okay, the admin part is going to be Alex as well. And now I just create. And with just these clicks, I'm just getting a running MongoDB instance. It's starting. Okay, it just takes a bit of time because you need to, to download the image and the container and starting the image and so on. Okay, now I've got my MongoDB up and running. I've got my LRA coordinator up and running. Then, let's deploy the booking seat system, which is here. I can do source main Kubernetes and kubectl apply -f kubernetes.yaml file. If you are curious about this file, it's just simple. Let's just see here that it's just a simple YAML file that has a service, and then I've got the deployment, and this deployment, well, here it has the container image. That's all, super simple. And I've got the seat booking service up and running, and of course, it's also a Quarkus application. And now let's deploy the payment. kubectl apply -f Kubernetes. And if I run it here, then you see that I've got the LRA coordinator, a seat booking that calls the payment, and have the MongoDB. Okay, I've got everything. The last thing I need to do before running the demo is create a route to access to this seat booking service. So I'm going to the administrator tab, going to networking, routes, create a new route, and put it here, for example, seat. And yeah, select the service, which is the seat booking, port 8080, create, and here we go. Here I've got the Quarkus Cinema reservation system. Now, let's go with the, let's say, the successful or the green path. Then I'll show you the code, and then let's simulate a failure. So I'm going to the, for example, to the 21. See that it says receive seat 21. I said yes. Now we've got the payment. Yeah, I need to pay. Then when I push this pay, I will connect to the payment gateway, and yeah, it says that it has been paid. Okay. Now let's see the code. I've got here the seat booking system. I've got the booking resource, as I said before. I've got here the error rate that requires a new macro transaction in the path /create. Well, in fact, this is /booking/create. And I'm just saying that, okay, I need to select an ID, and this ID is the Saga ID. Then I'm just starting the transaction. I persist it, and finally, if it works, then it says that, okay, it has been created. If not, then I just return an error saying it's already booked. If there is any kind of exception, I just put it here, add.print stack trace. Yeah, it's something that you should not do, but for the sake of simplicity, it's it's easier. Then I can go here and let me go back to the developer tool, because developer tool is something super cool, right? Because as a developer, you don't need to take care of a lot of things. And if I go to view logs, you see that it says payment success payment success, payment service response, blah, blah, blah. Okay, here it's the cluster of MongoDB. It's opened, and here, this is the starting transaction. This is the transaction that it's been started or it's been notified to the LRA coordinator. See that it says starting transaction, LRA coordinator 8080, and this is the ID of the Saga. This is the ID of the macro transaction. Then I've got here the creating booking for 21. And then finally it says, okay, transaction complete for this service. It's not committed, okay, but it says that Sorry, yeah, it's committed because I paid. Since I paid, it says that the transaction has been completed, and it says payment success, payment service response, blah 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 blah. Because this was the green path, so I just first of all I booked the seat, then I paid, and when I paid, the transaction finished, as it says here. If you want to see the logs, we can repeat it with the 22. Now I'm just going to do the reserve seat, and you see that it says creating booking for 22, starting transaction, but there is no transaction complete because I've not paid. Now when I paid, now I got it that the transaction completed. Now wait, here, transaction completed. Okay, then what's happened when I want to pay? When I want to pay, I'm just getting to the payment resource, which is in a /payment/pay. Again, I'm saying that this payment request should be inside a macro transaction that is identified by this LRA HTTP context header, and it basically pays. If it works, it says that payment service response. If not, it just says error. Okay, now the payment service, well, it's super stupid service. Here it is. We just say, I'm going to pay. I sleep like 1 second to simulate the transaction time. And finally, notice that I've got this Boolean. And in this Boolean, I'm saying, if it's true, then return an error. So we simulate a failure. If not, just return okay. In this case, by default, it's true. Now, let's change it. Let's go here. I'm going to topology. Close this. I'm going to payment. To the spot terminal. This is something that it's super cool that you can do with OpenShift. That with some clicks you just get if you want an SSH into this pod. It's not an SSH connection, but you get the point. So now this is inside that pod. I'm going to do curl localhost 8080/misbehave. No, because it's probably it's a /payment/misbehave. Okay, now what is the pay? Okay, pay. Okay. Okay, now it says that misbehaving. So now every time that I do a request to the payment service, then we will get an error. Let's go here again. I can go to the online cinema. Or wait, I can even do another thing that it would be interesting. Let me go to a seat, the booking resource. There is here a way to find all the seats that are inside MongoDB. And I'm going to just show you what seats are now. Let's go to a seat booking, the spot, terminal, curl, localhost 8080/booking/ that's all, /seat. Okay, perfect. /seat. You see that there are two seats, the 21 and the 22. Right now, remember that we said that payment is going to fail. I'm going to take the 11 seat. I do a receive seat. This is working because I've not paid yet. I've just reserved the seat. And if I'm going here and I do a curl, you see that it says 22, 21, 22, and 11, because from the scope of the seat reservation system, I've just reserved the seat in my database. But now it's time to pay. And when I push pay, you see, it says payment for reserved seat 11 failed. See that now it's green. And if I'm getting the curve, I'm just not getting the 11 anymore. Why? Because the Saga execution coordinator detected that one of these sub-transactions failed and then start sending requests to the services saying you need to compensate the failure of the transactions. And what it's doing in the case of the booking resource in the compensation method. It just finds the booking, and if it's present, because remember that I said that the compensation method must be idempotent. So it means that I can call this method several times, and it should not fail. I should get the same result. In this case, I'm setting if it's present, delete it, and then in this case, I'm just sending an SSA even to the front end, so they unselect the seed. So the seed, instead of being this red or brown, it's in green again. And that's pretty much everything that I would like to show you. Again, you've got the demo. You've seen how I just deployed. Just kubectl apply Kubernetes, kubectl apply Kubernetes, kubectl Kubernetes. That's all. Super easy. And you can play with this at home as well. That's all.
Oh, that's a great demo and great overview of the Saga part. And just a comment from one of our guests. Let's say it's more a complaint about your user experience skills. Is telling that yeah, the user interface is great, but so is not definitely from you.
Yeah, exactly. I mean, Sevi is totally right. It's just yeah, it was an example of that I found of LRA. Okay, but of microprofile LRA, they just developed an example, and they had this front end and said, okay, I'm going to just take the front end and develop, let's say, the backend in Quarkus. I checked the license, and it was Apache v2 license, so there's no problem to do that. But yeah, just
our guests are very high demanding, so the level of user experience skills are very high. So and let me ask you some suggestion, if you have it, regarding debugging of this very interesting pattern. In this case, we do have just 2 transactions to manage, but when we have more than 5, 6 comprised in one Saga pattern, do you have any advice, suggestion, indication how to manage it?
Yeah. In this case, it could be tricky. In fact, debugging microservice architecture can be tricky. And the good thing is that the LRI coordinator has an endpoint that you can get. For example, let me give me the current Saga transactions started. Give me all the sub transactions, or give me a Saga transaction. Give me the real estate of the Saga transactions. You can say, okay, now we are in this point, or in this other point, or now it's compensating, or it failed compensating this or that. So it offers this way. Okay. It's true that it's not easy, and also I would say that the log lines are pretty good as well in the Quarkus. So you see when I was demoing, they say starting transaction completed, and so on. So that's
so the 2, let's say, features combined together can help to do some debugging. Okay.
Yeah, but one of the great things about Saga pattern, I know that it's not. I mean, that it's not easy to debug, but it's not that hard, or they are not super hard, because all the pieces are isolated on its own. I mean that there is no magic. If you check the service, I've got an endpoint that is named /compensate, and I know that the Saga coordinator executor will run this endpoint when there is a failure. So I can simulate these failures on my own. I can just go there and do a curl to /compensate and see what's happening. So I know that it's not easy, but also let's say that it's reproducible. It's not something that it's somewhere stored in another piece of software that you don't know exactly what it's doing. And let me, for example, think about, suppose that you've got in the Kubernetes world, you can have a sidecar container that is doing some stuff. If there is something fails, how do you develop? I mean, like something failing in the sidecar container, or maybe not, but you don't know exactly what is this logic, right? Because it's inside a container that probably you do not develop. And in these cases, the code is there. It's your code. For the reason I said in the slides that this is a business transaction. It's the code that depends on your business logic, and it's there. So you can always try to see what's happening when there is a failure.
Yeah, right.
And Alex, there's a comment from Kevin in the chat. He say that there is an advantage of being able to decouple your system with increased flexibility of deployment and team segmentation. From his note, I would like to ask you, do you see this as a good trade-off between scalability and the need of having a transaction, the need of having this kind of feature? No, you can scale up your application, multiple cloud, whatever, but you need at some point to store the data in a consistent way. So how do you see this shift of paradigm from the single database, single application, then multiple microservices, but still with using transaction?
Yes, well, it may be problematic, and also I always say that, you read some books, and you always end up, but that depends a lot of your business use case. For example, I remember reading one use case which was about eventual consistency. This is another play or another kit on the ground that you can say, okay, I'm going to do eventual consistency, so I know that the system is not always updated to the latest and greatest. And for example, I remember that reading an example of booking a hotel room, the company decided it could be a good approach to use eventual consistency. And you might say, well, two people can just book the same room, right? Because it's eventual consistency. But it says, well, it doesn't matter. If I get the two hosts in the room and both has the reservation to the same room, then the latest one, so the one that gets the conflict, I will just offer and upgrade it to a better room. So he will not complain, right? And I can just deal with eventual consistency. Sometimes it's more about the business that you can apply rather than the technical solution that you can offer.
Right, that's a good point. Not as a problem, but as an opportunity, to a feature. That I like it.
Yeah. I read that it was doing this kind of things. Yeah.
And about distributed transaction pattern, we have a nice article in our developers.com blog written by our colleague Bilgin that talk about comparing distributed transaction pattern for microservices, like what Alex shown today, wrap it up in an article. So please check out also our blog on developers.com. We have multiple resources like this. That's very interesting. We have also the links in the chat for the demo. So Alex, for the demo, if I want to do the demo, can I do in today with you talk about sandbox? So to run this demo, I just need to go to sandbox and deploy stuff.
I mean that my sandbox account, it's just a regular sandbox account, so it's not an upgrade because I work in Red Hat and this is a Red Hat product, so I've got some privileges. Nothing, it's just a regular account. So you just need to clone my repo, do kubectl apply of all of the 3 kubernetes.yaml files that I put it there, and then you can just go to the sandbox and, as I show, start a MongoDB instance. So you can always rewatch this session to see how I've done. And also, if you are using Minikube, I just put it a stateful set for MongoDB there. So this stateful set doesn't work in OpenShift because of privileges and so on. But if you're using Minikube or Kine or any of these local clusters, you can. I also provided a YAML file to deploy the MongoDB instance. So yeah.
This is interesting, Alex. And I also wanted to ask you, so Kubernetes provides some way to manage application as stateful, no? Do you think also this kind of microservices need to be stateful in the Kubernetes way to define stateful application, or it's enough to consider as a generic stateless deployment and then the application logic will care about that?
Yeah, there's a lot of approaches here. For me, I know few companies that are managing everything inside the Kubernetes cluster, but most of the companies, probably because they are scared of losing its data, because data is the new oil, right? So they put the databases inside virtual machines, and all this state thing happens out of out of Kubernetes, and then they do this stuff outside the Kubernetes clusters. But I know some one bank here in Spain that they are using the wall. They're putting everything inside Kubernetes. They use NFS. In fact, they're using NTFS, I guess. NFS. Sorry. Yeah. No, they're using NFS for storing the stateful of all the applications. So yeah, there is both approaches, I would say.
Okay.
Interesting.
Okay. Obviously, there is not one solution that fits everything.
Yeah.
Any kind of
and
use case.
And depends also, of the experience that you've got. If you're really experienced in the Kubernetes ecosystem, then go ahead with this. But maybe you're just starting, so it's like, okay, let's just start, and step by step, let's get some confidence of the system, and then
Right. I think it's a good point, Alex. I think we ended the show with the right point, no? So use what is best for you, but there are solutions you can choose. So at least there's the freedom, the opportunity to choose the best solution. And I really like this the Saga pattern for distributed transaction in the microservices world. I think it was very valuable. So yeah, folks, if you there isn't any question in the chat, I think we can close up with reminder, Fabio. So we will come back next Wednesday, April the 6th, with a session talk called Quarkus Intro on OpenShift, made by our colleague Daniel. And for today, if you stay here, please stay together with us on OpenShift TV. We have the Level Up Hour, and Alex, today is Dev Nation Kubernetes Day. I think we can also share the link in the chat. Do you want to say something about Dev Nation Kubernetes Days?
Well, yeah, this is a day that with just, I think that it's like in 3 hours or 4 hours, you get it from basic Kubernetes until the super cool Kubernetes like Istio, Knative, Tekton, and so on. So you have a full vision of what is Kubernetes and what is under the Kubernetes umbrella, or what is the Kubernetes ecosystem, and what each of these things do when they are together with Kubernetes.
So I think Alex is also a nice warming up for KubeCon coming in May. So this is a kind of a start, no? Start dealing with KubeCon and Kubernetes stuff. I see there's a Kubernetes beginner, intermediate, advanced, Tekton, Istio service mesh, Knative serverless. Please register today to join the session. It's all live demos here, only live demos. So
we get the risk to fail, but yes, everything.
Yeah, of course. We try to manage, and thanks, Alex, for joining today. It was a pleasure to have you on OpenShift TV, and I hope you come back soon for another super cool live demo like this one of today.
Sure.
Yeah, Fabio, it's
time to close.
Okay? We can start to close.
Looking forward to the next session next Wednesday.
Next Wednesday, stay with us on OpenShift TV today. Stay with us for Dev Nation Day, and talk soon. Ciao.
Cheers. Bye.
Bye.